Let's take a look. For the very first time, an airless wheel conceptualizes spokes under tension. For the first time, spokes that stretch. Here are some simulations with a 4-inch diameter wheel model. Super Tweel is an airless wheel design. It cannot go flat. Spokes are under tension and can't stretch. Tire performance and suspension capability is similar to radial tires. Roll efficiency, durability, like radial tires. No design limitations that are restricting the Michelin Tweel. Michelin Tweel is inefficient like a soft, solid rubber tire, therefore no highway applications, collapsing sections in the footprint area. Noise, heat, bad gas mileage, bad steering control, bad braking with a fluttering footprint and a high rate of wear because of tread squirming. Simultaneous bad news from the opposite wheel, heavy vibrations, collapsing rubber sections, unresponsive load absorption in a small area like the outdated bias ply tire design. Depending on the load bearing down on the Michelin Tweel, this leads to a squirming tread band behaving in the way of an uncontrolled rubber blob. It lacks definition, which the Michelin design will never acquire, because a radial tire type tread belt together with the compression spokes would be hard like an old horse coach wheel. In emergencies, Super Tweel acts with swift, long suspension travel. Amazing vertical architecture, complete load distribution, therefore little tear and wear. Over obstacles, the top pulls down or inward, further reducing unsprung weight. The lower areas push out, lunging forward, down towards the pavement. Wonderful traction control, shifting back to form with perfect shape memory. In the intelligent design, lateral give is locked up and minimal. Key is efficient high-speed performance, an adaptive capability producing adhesion to the road surface that comes from the reactive speed in the structure. Only a structure under tension, like a pneumatic radial tire or an intelligent zero-pressure wheel like Super Tweel, perform in this way. A rubber sling using rubber bands is a good example for this reactive speed of tension release. Staying in this analogy, who has ever seen a toy glider launched by the energy release of a compressed rubber block? Over obstacles, smoothly, with speed. And in ordinary driving performance. Despite scale factors that any model would have, we observe a functional envelope of design parameters for the Super Tweel that is very broad. Choices can be made from a wide range of tread band and stretch spoke stiffness to accommodate different applications, different vehicle weights and different footprint sizes in a given diameter to exactly achieve a particular compromise between traction, fuel efficiency, vehicle weight range, etc. Success for taking the design to the stage of full-scale prototyping and eventually manufacturing is likely. With the Super Tweel, you are looking at the golden ratio of wheel design. By the way, when potholes or road unevenness come under the tread edge, Super Tweel maintains a full footprint contact and traction control. Super Tweel, a high-performance airless wheel, features spokes under tension, even stretching spokes, preferably in a 3-dimensional crisscross configuration that will provide lower roll resistance, a responsive short travel suspension, as well as excellent lateral authority, torque authority, and longevity. For questions, contact Mechanical Innovation at yknet.ca.